Hey there, space enthusiasts. It's Christmas Eve, and, well, we like to do things a little differently around here.
Definitely not your average holiday program.
Right. So we're kicking off the festivities with a deep dive into the cosmos, because why not? You guys send over some awesome articles about Asteroid 2024 XN1, that house-sized space rock that's paying Earth a little visit today.
It does add kind of a unique cosmic twist to the holiday season.
Totally. So we thought we'd explore, what this asteroid can tell us about things like the early solar system.
A fascinating glimpse into our cosmic past.
For sure. I've got some cool stuff about the hunt for resources in space, like helium-3.
Always a hot topic.
Yeah. And of course, we got to talk about how we protect ourselves from, getting smacked by one of these things.
Planetary defense is always a priority.
Okay, so first things first. This asteroid that's been making headlines, it's like seriously zooming past us today.
It is.
Over 14,000 miles per hour, something like that.
Yeah, something like 20 times faster than a speeding bullet, I believe.
Which is pretty wild.
Yeah.
But it is going to miss us, right?
Oh, yeah, by a comfortable margin. About 4.5 million miles, to be exact.
Okay, good. Still makes you think, though, like, how do scientists even keep track of all this stuff?
Yeah.
You mentioned NASA's Asteroid Watch dashboard, right?
Yeah.
How does that thing even work?
Well, NASA's got their eyes on the sky 24/7. That dashboard is basically constantly scanning for, for asteroids and comets that, come kind of close to Earth.
Right.
And it tracks all the important stuff, like how big they are, how fast they're going, how far away they are, and when they'll be closest to us.
So anyone can just, hop on there and see all this info?
Yeah, it's not just for scientists. Anyone can check it out, see what's zipping around out there.
That's so cool. So kind of like a cosmic neighborhood watch program.
I like that. Yeah, exactly. It's all about transparency and making sure everyone has access to this information. It's important, for understanding any potential threats and just, for keeping the planet safe.
Speaking of threats, let's talk about planetary defense. How seriously are we taking this whole asteroid impact thing?
Oh, it's definitely a serious concern. But, we're not just sitting around waiting for something to hit us. NASA and other space agencies, they're actively working on ways to protect our planet.
Like that DART mission, right? Where they basically crashed a spacecraft into an asteroid.
Exactly. DART was all about testing if we could actually nudge an asteroid off course.
Like a cosmic billiards shot.
Yeah, kind of. It was just a test, on a small asteroid that wasn't a threat. But it gave us some really valuable data to, figure out how to defend ourselves if a real threat ever pops up.
So we're getting better at dealing with those potential, end-of-the-world scenarios.
Mm-hmm.
But you've mentioned earlier that asteroids aren't just potential hazards. They're also what did you say, time capsules?
Right, like time capsules from the early solar system.
Whoa.
Yeah. They hold clues about how planets formed and what the solar system was like billions of years ago. It's like having access to a cosmic history book.
And what's one of the most exciting things we might find in that book? Helium-3, right?
You got it.
This potential fuel source has been getting a lot of buzz lately.
Helium-3 is pretty amazing, actually. It's a rare type of helium that's, super rare here on Earth, but could be really abundant on the moon and some asteroids. And the cool thing is, it could be used for fusion power.
Fusion power?
Yeah, a clean energy source that, could totally change how we power everything.
So clean energy from space rocks. That sounds like something straight out of a sci-fi movie.
It does, doesn't it? But the science behind it is totally real.
So, let's say we figure out how to mine helium-3 from asteroids. What would that even look like? How do you even begin to do something like that?
Well, it wouldn't be easy. Asteroids are millions of miles away, so just getting there and back is a huge challenge. And then there's the whole, how do we actually mine it part?
Right.
We'd need some serious advancements in technology, like better spacecraft, better robots, new ways of mining and processing the asteroids, and then, of course, figuring out how to transport all that helium-3 back to Earth.
Sounds like a pretty massive undertaking.
Yeah, it would be a huge project for sure. But the potential payoff, if we could unlock clean energy from space, it would be pretty incredible.
So it's a long shot, but it could be a game changer.
Absolutely. High risk, high reward, right?
Yeah. And speaking of risks and rewards, I think we got to talk about the ethical side of all this. What are the implications of going out there and basically, taking resources from space?
That's a really important point. We can't just go out there and grab whatever we want without thinking about the consequences.
Right.
We need some clear rules and regulations, make sure we're doing things responsibly and sustainably.
We don't want to mess up space, too.
Exactly. We've already done enough damage here on Earth. We've got to approach space exploration with a sense of respect.
Like we're guests in someone else's house.
Yeah, and we want to be good guests.
So asteroid mining might be a long way off. But the conversations we're having now about the ethics and the risks and all that, those are really important for shaping, how we approach space in the future.
Definitely. And it's not just about helium-3 either.
Right.
Asteroids have a bunch of other valuable stuff like platinum and gold, even water. And those resources, they could be really important for, future space exploration and maybe even space colonization someday.
Wait, water? What would we need water for in space?
Oh, well, first off, we need it to survive, but it can also be broken down into hydrogen and oxygen.
Right.
And those can be used as rocket fuel.
I
or
see.
even to create breathable air.
So, like, asteroids could be like cosmic pit stops for future space travelers.
Exactly. Imagine a network of asteroid mining stations out there. They could provide fuel and water and all sorts of other supplies.
Wow. So these space rocks that we're talking about, they might hold the key to, a whole new era of space exploration.
And maybe even help us solve some of the problems we're facing here on Earth.
It's like opening a present on Christmas morning and finding something you never knew you needed.
That's a great way to put it. And as we learn more about the universe, who knows what other amazing things we'll discover.
The possibilities are endless.
It really is mind-blowing to think that, the answer to our energy problems might be floating around out there somewhere.
Yeah, totally. It just goes to show how much we still don't know about the universe.
Yeah.
But before we get too carried away with all this like asteroid-powered future stuff, let's talk about the challenges of actually mining helium-3 from space. Like, what are the biggest hurdles?
Well, the challenges are huge. First of all, you've got the distance. We're talking about millions and millions of miles.
Right.
So even getting to an asteroid and back would be a massive undertaking. And then there's the whole, how do you actually mine it question? Like, we'd need to develop some totally new technologies to capture these asteroids, process them, extract the helium-3.
It's not like we can just send some guys up there with pickaxes.
No, not quite. We're talking about advanced robotics, specialized mining equipment, and, figuring out how to transport all that helium-3 back to Earth.
So it's basically like building a giant mining operation in space on a moving target.
Yeah, it's a pretty wild concept. And even if we could pull it off, there's the whole economic side of things.
Right, of course.
The cost of all this would be astronomical.
Pun intended.
Maybe. But seriously, it's unclear if mining helium-3 from asteroids would even make sense, economically.
Compared to other clean energy options?
Exactly.
So it's a huge gamble, basically.
Yeah, you could say that. High risk, high reward.
For sure. But it's not just about the money, right? There are ethical considerations, too. Like, is it even okay for us to just go out there and take resources from space?
That's a really important question. We can't just treat space like, the Wild West.
Right. There are no rules out there.
Well, there should be. We need to think about the long-term consequences of our actions. We don't want to repeat the mistakes we've made here on Earth.
I hear you. We've got to be more responsible this time.
Exactly.
Yeah.
We need to approach space exploration with, a sense of stewardship, recognize that we're part of this larger cosmic ecosystem.
So asteroid mining might be a while off, but it sounds like the conversations we're having now about the ethics and the impact and all that, those are crucial.
Absolutely. And it's not just about helium-3 either. Like we said, asteroids have a bunch of other valuable resources, things like platinum and gold and even water.
Water. Okay, now I'm really curious. What would we even use water for in space?
Well, besides the whole keeping humans alive thing.
Right, of course.
Yeah.
Can't forget about that.
Water can also be broken down into hydrogen and oxygen.
Uh-huh.
And those can be used for rocket fuel.
Oh, right.
Or even to create breathable air.
So, like, asteroids could be like cosmic gas stations.
Exactly. Imagine a network of asteroid mining stations spread out across the solar system. They could provide fuel, water, other supplies for spacecraft.
That's a pretty cool vision.
It's called in situ resource utilization, or ISRU for short. And it could totally change the way we explore and, maybe even colonize space someday.
So these seemingly insignificant space rocks that we're talking about, they could be the key to unlocking a whole new era of space travel.
And maybe even help us address some of the challenges we're facing here on Earth, too.
It's like that saying, one man's trash is another man's treasure. Right?
Something like that. The universe is full of surprises.
Yeah.
And as we continue to explore, who knows what we'll find?
Wow. As we wrap up this deep dive into the world of asteroids, I got to say, I'm feeling kind of, I don't know, awestruck. Like, just thinking about how massive and mysterious the universe really is.
It's humbling, isn't it?
Totally. But at the same time, it's pretty amazing that we, like tiny little humans, we have the ability to actually go out there and explore it all, unlock those secrets, maybe even use those resources to, make things better here on Earth.
That's the beauty of space exploration, right? Always pushing the boundaries.
Exactly. It's like we're constantly uncovering new chapters in this cosmic story.
And with each new discovery, our perspective changes, We get a little closer to understanding where we fit into it all.
Yeah, for sure. But, as we learn more, it seems like we end up with more questions like, how do we balance all this excitement about exploration with, being responsible?
Right. How do we make sure that what we do out there in space, that it benefits everyone, not just, a select few?
Big questions.
Big questions indeed. But that's why these conversations are so important. Thinking about the ethics, the long-term consequences, it's not always easy, but these are challenges worth tackling.
Because ultimately, space exploration is about so much more than just, rockets and science and all that. It's about inspiring people, pushing the limits of what's possible.
And maybe, just maybe, helping to bring humanity a little closer together.
So as we, enjoy this Christmas day, let's take a minute to appreciate how far we've come. From that close call with Asteroid 2024 XN1 to, all this mind-blowing talk about asteroid mining and the future of space exploration.
So we found this article from the Times of India. It's all about NASA's Asteroid Watch program. And get this, it says 5 asteroids will be passing by Earth in the next few days. Yeah, you heard that right, 5.
And the interesting thing is that these asteroids, even though none of them are going to hit us, can actually teach us a lot about how we track them and just what kind of risks they pose.
Okay, so let's break this down a little bit. The article starts off by talking about this one asteroid, Asteroid 2024 XN1, and it's supposed to come closest to Earth on December 24th. Talk about a Christmas Eve surprise, right? The article says it's about 120 feet wide, which they compare to the size of a Boeing 737. I can't even imagine seeing something that big flying through space.
Yeah, that's a pretty good comparison to help visualize it. And if you think about the energy something that big carries, even if it were to break up in the atmosphere, the impact could be pretty significant. Like, remember that meteor that exploded over Chelyabinsk back in 2013?
Oh, yeah, that was scary. Thousands of people got hurt from that airburst, and that was a fraction of the size of this 2024 XN1. Speaking of size, the article also mentions this thing called TDB, barycentric dynamical time, and that astronomers use it to track these asteroids. It sounds super technical to me.
It is a pretty technical concept, but it's crucial for accurate tracking. You can think about it like coordinating a meeting with someone who's in a totally different time zone.
Yeah.
You need that common reference point. And well, TDB provides that for astronomers. It lets them pinpoint the location of things in space relative to the solar system's center of mass.
Yeah. Okay, so it's like a universal time zone for space.
Got it. So this article says that this asteroid is traveling at 6.59 kilometers per second. That's over 23,000 kilometers per hour. So you're trying to tell me this massive rock is hurtling towards us at that speed, and I shouldn't be worried.
Well, towards us is a little bit relative here. That speed is its velocity relative to Earth. But it's important to remember that asteroids are constantly influenced by the gravity of the sun and all the other planets out there. So, their actual paths and speeds are constantly changing as they move through space.
So it's less like a straight line and more like some kind of crazy cosmic dance with gravity pulling it every which way.
Exactly. And yeah, 23,000 kilometers per hour sounds unbelievably fast, but that's pretty typical for asteroids.
Okay, but this speed demon isn't alone, right? The article mentions a few other asteroids passing by Earth around the same time.
Yeah, there are actually 4 others. And this is where NASA's Asteroid Watch program comes in. They're constantly monitoring near-Earth objects of all sizes to see, if there are any potential risks. So how do they determine which ones are worth worrying about?
Well, they have this classification system. Any object that's bigger than 150 meters, about 500 feet, and also comes within 4.6 million miles of Earth, gets flagged as potentially hazardous.
Okay, so anything bigger than a football field that comes closer to us than the moon, basically. So are any of these 5 asteroids that we're talking about in that potentially hazardous category?
Thankfully, no, none of these 5. But their close approaches highlight how important this constant monitoring is. We need to keep an eye on things, and we'll talk a little more about that later.
Okay, I'm definitely interested to hear more about that. But first, let's talk a little bit more about those other 4 asteroids. The article mentioned that they're all smaller than this 2024 XN1, right?
Yes, much smaller. They range in size from about 100 feet to as small as, get this, 44 feet.
44 feet, seriously, that's like the size of a school bus. Are you saying a school bus-sized rock is flying through space near Earth?
I know, it sounds a little funny. But it's a good reminder that even pretty small asteroids can have a big impact, literally. If something that size made it into the atmosphere, it could still cause some regional damage, especially if it hit near a populated area.
Okay, now I'm starting to understand why NASA takes this asteroid tracking stuff so seriously. So tell me more about these other 4 asteroids. Are any of them particularly interesting, or are they just your average, everyday space rocks?
Well, they might not be as dramatic, as that Christmas Eve asteroid, but they're all kind of unique in their own way. Like there's this one 2016 CZ31, and this is actually its second close approach to Earth in just a few years.
Oh, wow. So it's like a repeat visitor, like that one friend who always pops up unexpectedly. Space is pretty big, though. So I'm guessing the chances of running into the same asteroid twice must be pretty slim.
You got it. It really shows you just how much is happening out there in space that we usually don't even think about. And actually, speaking of slim chances, another one of these asteroids, 2020 XY4, is on what's called a retrograde orbit.
Retrograde, what does that mean?
So you know how most asteroids orbit the sun in the same direction as all the planets? Well, a few like this one actually orbit in the opposite direction.
Wow, so it's like swimming against the current out there in the solar system. So we've got a repeat visitor and a rebel in this group. Any other interesting characters?
Well, the last two, 2021 JA5 and 2023 WX1, are pretty interesting because they're really different sizes. Like 2021 JA5 is about the size of a house, while 2023 WX1 is closer to that school bus size we were talking about earlier.
Yeah.
It just really highlights how even relatively small objects can be a threat, especially if they come in at a sharp angle.
Okay, so we've got these 5 asteroids, all different sizes, zipping past Earth in the next few days. NASA's keeping track of them, and thankfully none of them are considered an immediate threat. But it makes you wonder, what's the big deal here? Why does NASA go through all this trouble to track these asteroids? Is it just about preventing, another dinosaur extinction event?
It's definitely a lot more than that. You see, tracking asteroids is actually super important for understanding how our solar system formed and evolved. These space rocks, they're like little time capsules. They hold clues about how planets first formed and the conditions in the early solar system billions of years ago.
Oh, so it's like solving a giant cosmic puzzle.
Exactly. And the more pieces of the puzzle we have, the clearer the picture becomes. And then, of course, there's the very practical reason for tracking them, and that's planetary defense. We know for a fact that Earth has been hit by asteroids in the past, and it will happen again. It's not a question of if, but when.
Yeah, it's hard to forget what happened to the dinosaurs, though I have to admit, when I hear about all these asteroids flying past, a little part of me does wonder, what if? What if one of these did hit us? What would we do?
Well, that's the million-dollar question, isn't it? And it's a question scientists all over the world are working on right now. There are a few different strategies being explored, but they all rely on one thing: early detection. The more time we have, the better our chances of deflecting a potentially hazardous asteroid.
So it's not just about knowing where these asteroids are, but also where they're going and how much time we have to react.
Exactly. And that's why programs like NASA's Asteroid Watch are so important. They're constantly monitoring and analyzing the data, calculating trajectories, and essentially giving us a heads up if something seems like it might be on a collision course with Earth.
So it's like a cosmic early warning system. That's pretty cool. So what are some of these deflection strategies they're looking into? Are we talking about blowing them up like in the movies?
Well, Hollywood likes to keep things simple, but blowing up an asteroid would probably cause more problems than it solves. A more realistic approach is what's called a kinetic impactor.
A kinetic what?
It's just a fancy way of saying we smash a spacecraft into the asteroid at a really high speed to try to knock it off course. It's kind of like playing a cosmic game of billiards.
So we're playing pool with asteroids. That sounds kind of fun. But wouldn't that take some serious precision? I mean, space is a pretty big place to be aiming a spacecraft.
You're absolutely right. It would take incredibly precise calculations and perfect timing. But remember, we're not trying to destroy the asteroid, just nudge it slightly off course. Even a tiny change in trajectory over a long enough period of time can make a huge difference.
Okay, so a little cosmic nudge in the right direction. Are there any other strategies they're thinking about?
There's another pretty cool concept called a gravity tractor.
A gravity tractor. That sounds straight out of a sci-fi movie.
It does, doesn't it? But the idea is actually fairly simple. You essentially park a spacecraft close to the asteroid and use its gravitational pull to slowly tug the asteroid away from Earth over time.
So it's like a cosmic tow truck.
Pretty much. It's a much gentler approach.
Yeah.
And it would be more effective on smaller asteroids or ones we detect far in advance.
This is all so fascinating. It really makes you appreciate how much effort goes into keeping our planet safe from these cosmic threats. It's not just about telescopes and watching the skies. It's about physics and engineering and even strategy.
And international cooperation, too. Don't forget, this isn't a problem for just one country. This is a global issue, and we need a global response.
That's a great point. So back to these 5 asteroids that are making headlines. What's NASA's current plan? Are they just monitoring the situation, or are there any specific actions being taken?
Right now, they're just monitoring things closely. But remember, none of these 5 pose any immediate danger. They're more like a reminder that we need to stay vigilant and keep investing in planetary defense research.
And a reminder that we live in a dynamic and unpredictable solar system.
Hmm.
Speaking of unpredictable, this whole conversation has got me thinking, what if we did find an asteroid that was on a collision course with Earth? What would happen? Would there be any warning? Would everyone freak out?
Well, those are all very good questions. It would be a pretty big deal for sure. But I think, people would be surprised to learn that scientists and governments all over the world have actually been working on planetary defense plans for a long time.
So there are already plans in place. We wouldn't just be, totally caught off guard.
Exactly. There are actually protocols for how to communicate, coordinate things, and even evacuate people if it came to that.
Okay, that makes me feel a little better. But still, it's kind of hard to wrap your head around something like that. It really puts things into perspective, doesn't it? All our little problems here on Earth seem so insignificant when you think about the vastness of space and the potential for, cosmic events like that.
It's true. It's amazing how something like the threat of an asteroid impact can really make us realize that we're all part of something so much bigger and that we really need to work together to face these challenges that affect every single person on the planet.
Totally agree. It reminds us that we're all Earthlings, sharing this planet and dealing with the same cosmic realities. So on that note, for our listeners out there who want to learn more about asteroids and planetary defense or just want to stay up to date on what's happening in space, what would you recommend?
Well, NASA's Asteroid Watch website is a great place to start. They have all the latest news and data and even some educational resources. You can even sign up for alerts if an asteroid is making a close approach to Earth.
Wow, really? So you can get like a text message saying, hey, an asteroid is passing by Earth today.
Pretty much. It's a pretty
Yeah.
cool way to stay connected to what's happening out there.
That's awesome. I'm definitely going to check it out. So as we wrap up this deep dive into the world of asteroids, any final thoughts?
I think the most important thing to remember is that while an asteroid impact is something we need to take seriously and prepare for, it's not something to panic about.
Hmm.
Scientists are always monitoring the skies, and our ability to detect and track these objects is getting better all the time.
Right. And even if we did find one headed straight for us, it's not like we're helpless. We have some incredibly smart people working on this problem. And like we talked about today, there are strategies we could use to deflect the asteroid, or at least lessen the impact.
Absolutely. So instead of being afraid of the unknown, let's focus on the wonder and excitement of space exploration. Keep looking up at the stars, keep asking questions, and stay curious about all the incredible things that are happening out there in the universe.
Well said. And on that note, a big thank you to you for joining us on this deep dive into asteroids and planetary defense. And to all our listeners out there, thanks for exploring with us. Until next time, keep wondering about the cosmos and all its mysteries.